90 days, 500 trees, 50 men with axes and handsaws. No lumber yard, no hardware store, no power tools, just virgin forest and the determination to build a town from nothing. By the end of summer, there would be 30 houses, a general store, a church, a school, and a sawmill, all built from trees that were standing in the forest on the first day of construction. The timber would be cut by hand, shaped with axes and adzes, assembled with wooden pegs and hand-forged nails. The buildings would be raised by muscle power and simple machines, block and tackle, levers, and human coordination. This was how America built towns in the frontier era, not gradually over decades, but rapidly over a single construction season. A community created from forest in 3 months, because there was no other choice. Winter was coming and people needed shelter. So they cut trees and built buildings faster than seems possible. This was frontier America in the 1800s, and new settlements were being established constantly. Homesteaders, miners, railroad workers, loggers, they'd arrive at a location that was nothing but forest, and within months, they'd have built a functional town. The speed of construction was driven by necessity. You couldn't order lumber from elsewhere. There were no transportation networks. You couldn't buy prefabricated components. There were no factories producing them. You had to use what was available locally, which meant timber. And you had to work fast because winter would shut down construction, and people needed houses before snow fell. Could 50 men really build an entire town in 90 days using only hand tools? Could they cut 500 trees, mill them into lumber, and construct dozens of buildings in a single summer? And could they do it without modern equipment, working entirely with axes, saws, chisels, and muscle power? The answer is yes. The evidence exists in the frontier towns that still stand, in construction records preserved in historical societies, and in the accounts of the workers who did the building. Before we get to how they did it, you need to understand what building a town meant in frontier context. Because this wasn't constructing a modern town with paved streets and utilities. This was creating basic shelter and essential buildings fast enough to support a community through the coming winter. A typical frontier town being established in the 1850s to 1880s might start with 30 to 50 families, or 100 to 200 individual workers. The construction priorities were determined by immediate needs. First, shelter, houses or bunkhouses where people could live. Second, a store where supplies could be purchased and sold. Third, a church for community gathering and religious services. Fourth, a school for children. Fifth, specialized buildings based on the town's purpose. A sawmill for a logging town, a stamp mill for a mining town, a grain elevator for a farming town. The typical house in a rapidly built frontier town was not elaborate. It might be a single-room log cabin, 16 by 20 feet, with a loft for sleeping. Or it might be a frame building with 2 or 3 rooms, a common area, 1 or 2 bedrooms, and perhaps a separate kitchen. The construction was functional rather than decorative. The goal was weather-tight shelter that would get people through winter, not architectural beauty. The construction process started with site selection and timber harvest. A crew would scout the surrounding forest looking for suitable trees. The requirements for building timber were different than for saw logs. For cabin construction, you wanted straight trees of consistent diameter, typically 10 to 12 inches for log walls. For frame construction, you wanted larger trees that could be sawn into dimensional lumber, 2x4s, 2x6s, boards for siding and flooring. The felling of building timber followed the same techniques used in commercial logging, but on a smaller scale and with different selection criteria. The fallers would choose trees, cut them, and buck them to the required lengths. For a log cabin, that might be 16-foot logs for the walls. For frame construction, it might be 20-foot logs that would be sawn into shorter pieces at the mill. The number of trees required for a town was substantial. A single log cabin might use 40 to 50 logs for the walls, plus another 20 logs for floor joists and roof rafters. That's 70 trees for one cabin. For 30 cabins, you'd need over 2,000 trees just for the basic structures, not counting the larger buildings. The 500 tree number in our example probably represents just the first phase of construction, the essential buildings erected in the first 90 days, with additional timber harvest continuing afterward. The hauling of logs from the forest to the construction site was done with oxen or horses. A team of oxen could drag several logs at a time if the terrain was favorable. The logs would be chained together and pulled along skid roads or directly over the ground. For a town site that was in or near the forest, hauling distances might be only a few hundred yards. For a site on a prairie or cleared land, logs might have to be hauled several miles. The sawmill was typically one of the first structures built because it was essential for producing dimensional lumber for frame buildings. A frontier sawmill was a simple structure, a shed covering a saw blade powered by water, horses, or sometimes steam. The saw blade would be mounted vertically, and the logs would be moved past it on a carriage, cutting board after board from each log. A water-powered sawmill required a reliable stream with sufficient flow. The mill would be built at the stream, with a water wheel driving the saw blade through a system of gears and shafts. The construction of the mill itself, the building, the water wheel, the saw mechanism, might take a crew of 10 men 2 to 3 weeks. But once operational, the mill could produce several thousand board feet of lumber per day, dramatically accelerating the construction of frame buildings. The water wheel was typically an overshot design, where water was directed onto the top of the wheel, filling buckets that would pull the wheel around as they descended. The wheel might be 12 to 16 feet in diameter, made from heavy timbers assembled with wooden pegs and iron hardware. Building the water wheel required skilled carpentry and metalwork. The axle alone might be 12 inches square and 20 feet long, turned from a single large timber and fitted with iron bearings. The saw mechanism used a vertical blade called an up and down saw or sash saw, mounted in a frame that would move vertically, driven by the water wheel, through a connecting rod and crank. The blade was typically 4 to 6 feet long, with large teeth that could cut through green timber. The blade had to be maintained carefully, tensioned properly, sharpened regularly, and replaced when it developed cracks or wore thin. The log carriage was a framework that held logs and moved them past the saw blade. The carriage moved on rails or rollers, pushed by hand or by mechanical feed mechanisms. The sawyer operating the mill would position a log on the carriage, make a cut, advance the carriage by a set distance, make another cut, and repeat until the log was completely sawn into boards. The speed depended on log size and desired board thickness, but an experienced sawyer could process perhaps 20 to 30 logs per day through a simple mill. The lumber produced at a frontier sawmill was often rough cut and of variable quality. The saw blade might wander slightly as it cut, creating boards that weren't perfectly straight or uniform in thickness. But for frontier construction, perfect lumber wasn't required. Boards that were roughly 2 inches thick could serve as framing lumber. Boards roughly 1 inch thick could be used for siding. The dimensional variation was accommodated in the construction techniques. The positioning of the sawmill relative to the town site and timber supply was a logistical consideration. Ideally, the mill would be close enough to the construction site that lumber could be hauled easily, but positioned where water power was available and where logs could be delivered efficiently. Sometimes this meant the mill was a mile or more from the main town site, requiring dedicated teams for hauling lumber back and forth. A horse-powered sawmill was used where water power wasn't available. These mills used a horse walking in a circle, turning a central shaft that drove the saw through gears. Horse mills were slower than water mills, perhaps producing a few hundred board feet per day rather than several thousand, but they could be positioned anywhere and required only the construction of the mill building and mechanism, not a water wheel and associated infrastructure. The organization of mill operations required coordination between the logging crews bringing in logs, the mill crew cutting lumber, and the construction crews using the lumber. If lumber production fell behind, construction would stall. If logs weren't delivered steadily, the mill would sit idle. The mill superintendent had to balance these flows, ensuring continuous operation while avoiding stockpiling too much lumber that would tie up capital and space. The typical construction sequence for a frontier town started with the most essential buildings and expanded outward. The first structure might be a large communal bunkhouse, where everyone would live while building everything else. This bunkhouse might be a simple log structure, 40 by 60 feet, with bunks along the walls and a central cooking area. Getting this first building up quickly was critical because it provided shelter for the workers. With the bunkhouse complete, work would proceed on multiple fronts. A crew would build the sawmill. Other crews would begin constructing individual family houses. A third crew might work on the store building. The work was organized to maximize efficiency. Crews specialized in specific tasks and worked in parallel, rather than building one structure completely before starting the next. The log cabin construction technique used for many frontier buildings was relatively quick for experienced crews. The standard method used horizontal logs, notched at the corners to interlock. The notching was done with axes, cutting away wood to create interlocking joints that would hold the logs in place. The most common notch was the saddle notch, where a curved cut in the bottom of one log fit over the top of the log below. The selection of logs for cabin walls required judgment. The ideal log was straight, relatively uniform in diameter, and free of excessive branching or defects. For a cabin wall, logs were typically 10 to 12 inches in diameter. Smaller logs would provide insufficient insulation and strength. Larger logs were unnecessarily heavy and difficult to handle. The length had to match the cabin dimensions. For a 16-foot wide cabin, you needed logs at least 16 feet long, preferably 18 feet to allow for trimming and the overhang at corners. The preparation of logs for wall construction started with removing the bark. This was done with draw knives or specialized barking tools. Bark left on logs would harbor insects and would eventually deteriorate, creating gaps in the wall. The debarking process was labor-intensive. A man might debark 10 to 12 cabin logs in a day of steady work. The foundation for a log cabin was typically simple. Stone piers might be placed at corners and intervals along walls to keep the first log course elevated above ground moisture. In some cases, the first logs, called sill logs, would be placed directly on the ground after leveling and preparing the site. This was faster, but resulted in faster deterioration of those lowest logs from ground contact and moisture. The corner notching technique determined how logs would interlock and how weather-tight the corners would be. The saddle notch was most common because it was relatively quick to cut and created a reasonably tight joint. The notch was cut with an axe, chopping away wood in a curved depression that would fit over the log below. An experienced notcher could cut a saddle notch in 10 to 15 minutes. For a cabin with 4 corners and 40 logs, that's about 10 hours of notching work. Other notch types included the dovetail notch, more complex but creating tighter corners, and the square notch, simpler but less weather-tight. The choice depended on available skill and time. A rapid town-building operation typically used saddle notches because they offered the best balance of speed and quality. The process of raising log walls required coordination. The first course of logs would be placed on the foundation, positioned carefully to create square corners and proper dimensions. Each subsequent course would be notched and positioned one log at a time. For the lower courses, 4 men could lift and position a log relatively easily. But as the wall rose, by the 8th or 9th course the logs might be 8 feet above the ground. Lifting became more difficult and required ramps or simple block and tackle rigs. The gaps between logs, spaces that would inevitably exist even with good notching and straight logs, would be filled with chinking material. This was typically done after the walls were complete and before roofing began. Workers would pack chinking material into the gaps from both inside and outside. Moss was common in forested areas. Clay mixed with straw or grass was used in prairie areas. The chinking had to be flexible enough to accommodate log movement as they dried and settled, but cohesive enough not to fall out. A crew of 4 men could notch and place perhaps 10 to 12 logs per day on a cabin. For a cabin requiring 40 logs for the walls, 10 logs high on each of 4 walls, that's 4 days of log work for an experienced crew. Add a day for floor joists, a day for roof rafters, and you have a basic structure in 6 days. Then came the detail work, cutting openings for doors and windows, chinking the gaps between logs, installing a roof, building a chimney, finishing the interior. The cutting of door and window openings in a completed log wall was done after the walls were up. This saved time during construction because you didn't have to work around openings while stacking logs. The opening would be marked on the wall, then cut out with a saw. The cut ends of logs would be secured by nailing vertical boards on either side of the opening to prevent the logs from shifting. This technique was faster than notching logs to create openings as the wall was built. The floor of a log cabin might be simple packed earth, wooden puncheons, split logs with the flat side up, or, if time and materials permitted, sawn boards. An earth floor was fastest, just level and pack the dirt. Puncheon floors required splitting suitable logs and laying them flat side up, which took a day or two. Board floors required either bringing in milled lumber or hand sawing boards with a pit saw, which was time-consuming but created the best floor. The chinking of log cabins was done with whatever materials were available. In forested areas, moss was commonly used, packed into the gaps between logs and held in place with wooden strips. In prairie areas, clay or mud might be used. The chinking had to seal the gaps to keep out wind and rain, but also had to accommodate the fact that logs would shrink and settle as they dried. A cabin chinked too tightly might develop cracks as the logs moved. The roof construction for frontier buildings used various techniques, depending on materials available. A simple log cabin might have a roof of wooden shakes, thin boards split from cedar or pine and laid like shingles. Shakes were made by splitting straight-grained wood with a froe, a cleaving tool with a blade set at a right angle to the handle. A skilled worker could split hundreds of shakes per day from suitable logs. The larger buildings, church, school, store, required more sophisticated construction than simple log cabins. These were typically frame buildings with sawn lumber for the structure and boards for siding. The framing technique used dimensional lumber, 2x4s for studs, 2x6 or larger for joists and rafters. The joints were typically mortise and tenon for major connections, or simple nailed butt joints for less critical connections. The raising of a frame building required coordination and muscle power. The wall frames would be assembled flat on the ground, all the studs, plates, and bracing components fitted together. Then a crew would lift the entire wall frame into vertical position using pike poles and rope. With the wall vertical, it would be braced temporarily, then connected to adjacent walls. A typical wall frame for a building 30 feet long and 12 feet high might weigh several hundred pounds. Raising it required 10 to 15 men coordinating their effort. Among the frontier builders was a man named Samuel Johnson, who worked on town construction in Kansas and Nebraska from 1867 to 1885. Johnson kept a journal that was preserved by his descendants. His entries describe the work and the pace of construction. From July 1871, writing about building a town in western Kansas, "We are 60 men building a settlement from nothing. We arrived on June 1st to find only prairie and a creek with timber along its banks. Today is July 10th, and we have completed 12 houses, a store building, and a church. The sawmill is operating and producing lumber rapidly. We work from dawn until dark, 6 days per week. Sunday is for rest and services in the church we built. The pace is brutal but necessary. Snow will come in 3 or 4 months, and we must have shelter for all families before then. Johnson's journal describes the organization. We are divided into crews. I am on the framing crew for houses. We build the frames and raise them. Another crew follows behind us doing the siding and roofing. A third crew does the finish work: windows, doors, floors. We complete perhaps 2 houses per week. Each crew specializes in their task and becomes efficient at it. This specialization is how we build so fast. Johnson also describes the timber work. The logging crews are cutting constantly. They bring logs to the mill site, where the mill produces lumber. The mill runs from dawn until dusk, the saw screaming through wood. We can hear it across the whole town site. The sound of the saw and the sound of hammering. These are the sounds of the town being built. A later entry from September 1871 describes the completion. The town is essentially finished. We have 32 houses, the store, the church, the school, and various outbuildings. Every family has shelter. The store is stocked and operating. Church services are held Sunday. The school will open next week with 20 children enrolled. We accomplished this in 4 months. It seems impossible when I write it, but I was here and did the work. My hands are calloused, my back aches constantly, but we built a town from forest. That is something to be proud of. Johnson also recorded injuries and difficulties. James Morrison fell from a roof 2 days ago. He was working on the church building when he lost his footing. He fell 20 feet and broke his leg badly. We have no doctor. We set the leg ourselves as best we could. James is in great pain, but there is nothing more we can do. He will recover or he will not. This is the frontier, and we accept these risks. Another documented builder was Eric Lindstrom, a Swedish immigrant who worked on frontier construction in Minnesota from 1872 to 1890. Lindstrom's letters to his family in Sweden, preserved in a historical society collection, describe both the work and the living conditions. From a letter dated August 1874. I am working to build a new town in the forest. We are 40 men and we have been working for 2 months. We have built 18 houses, a store, a church, and a school, all built from trees we cut ourselves. The work is constant. We wake at dawn and work until we cannot see anymore. The food is adequate but plain. We sleep in a large bunkhouse, 40 men in 1 room. There is no privacy and little comfort. But the pay is good, and the work will not last forever. Lindstrom describes the house construction technique. We build with logs cut from the forest. The logs are notched at the corners and stacked to make walls. The gaps between logs are filled with moss. The roofs are made from wooden shakes. A good crew can build such a house in 1 week. I am learning this work and becoming faster. Last week, our crew completed 2 houses. This week, we will attempt 3. A later letter from October 1874 describes the approaching winter and completion. The town is nearly finished. We have 20 houses completed and occupied. The store is operating. The church holds services. The school is teaching. But winter is coming early this year. Snow fell yesterday. We are rushing to complete the last few houses before deep cold makes work impossible. Several families are living in partially finished houses, enduring cold to be in their own homes rather than the bunkhouse. This is hard, but they accept it. Lindstrom also describes an accident. A man named Otto Svensson was killed last week. He was working on a roof when he slipped on wet boards. He fell and struck his head on a log. He died within the hour. We buried him in a plot near the church. His wife and 3 children are now alone. The company paid for the burial, but offered nothing more. This is the way of frontier life. We work until we are injured or killed, and then others take our places. A third documented worker was Thomas O'Brien, an Irish immigrant who worked as a carpenter on frontier construction in the Dakota Territory from 1878 to 1886. O'Brien's testimony appears in a lawsuit filed after he was injured in a construction accident. The court records include his description of the work and conditions. O'Brien testified that he worked as a framing carpenter, earning $3.50 per day. Good wages for skilled work. He described a typical workday. We would wake at 5 in the morning, breakfast at 5:30, in the work site by 6. We would work straight through until noon, with perhaps one short break. Lunch from noon to 1. Then work until 7 or 8 in the evening, depending on light. That's 13 or 14 hours of work, 6 days per week. On Sunday we rested, though some men would work on their own projects or repair tools. O'Brien described the framing work. We would cut the timber for a house frame and assemble it flat on the ground. The posts, beams, braces, all fitted together with mortise and tenon joints. When the frame was complete, we would raise it. This required all available men, perhaps 20 men to raise the frame for a large building. We would use pike poles and ropes to lift the frame vertical. Then we would brace it temporarily until the other walls were raised and connected. This work was dangerous. If a frame fell while being raised, men could be crushed. O'Brien was injured in 1884 when a frame being raised shifted unexpectedly and fell. According to his testimony, we were raising the frame for a store building. The frame was perhaps 30 feet long and 15 feet high. 20 of us were lifting it with poles and ropes. The frame reached vertical, and we were setting braces when something failed. A rope broke or a brace gave way. The entire frame fell backward. I was directly behind it and was struck. My shoulder and arm were crushed. I was unconscious for 2 days. When I woke, my arm was useless. The company paid for medical treatment, $30. Then they dismissed me because I could no longer do the work. I am 34 years old, and I cannot work as a carpenter. I have a wife and 4 children. This lawsuit is my only hope for compensation. The court awarded O'Brien $200, about $6,000 in modern currency, noting that while the accident was unfortunate, the risks were inherent in the work, and O'Brien had accepted them by taking employment. The speed of frontier construction was driven by economic factors as well as necessity. Workers were typically paid by the structure or by day wages that incentivized rapid completion. A carpenter might earn $3 to $4 per day, good wages for the era. But the work was only available during the construction season. Workers had to earn enough during summer and fall to support themselves through winter, when construction largely ceased. The specialization of labor that Johnson mentioned was critical to the pace of construction. In a town building operation, crews would develop specific expertise. The logging crew became efficient at felling and bucking trees. The sawmill crew learned to operate the mill at maximum production. The framing crews became fast at cutting joints and assembling frames. The roofing crews developed techniques for installing shakes or boards quickly. This specialization meant each crew was doing what they did best, maximizing overall productivity. The coordination of multiple simultaneous construction projects required a superintendent or foreman who could manage the workflow. This person would ensure that lumber was being produced at the rate needed for construction, that crews had the materials they needed when they needed them, and that the various projects were proceeding in the correct sequence. Poor coordination could result in crews standing idle, waiting for materials, or trying to work on a structure that wasn't ready for them. The quality of frontier construction varied considerably. Buildings erected in a rapid town building operation were functional, but often crude. The focus was on creating weather-tight structures quickly, rather than on fine craftsmanship. Logs might not be perfectly straight. Joints might not fit precisely. Boards might have gaps. But the buildings served their purpose, providing shelter and enabling the community to survive. The church building in a frontier town was often one of the more substantial structures, both because it served as a community gathering place and because it needed to accommodate the entire population for services. A typical frontier church might be a frame building 30 by 50 feet, with a peaked roof and perhaps a small bell tower. The construction would follow standard frame building techniques, but with attention to creating a more finished interior than a typical house. The school building was similar in size to the church, but with different interior arrangements. A frontier school might have a single large room where all grades would be taught together, or it might have two rooms dividing younger and older students. The building would include a teacher's desk, student benches or desks, a wood stove for heat, and perhaps a separate cloakroom where children could hang their coats. The store building was a commercial structure that needed to accommodate merchandise, display, and storage. A typical frontier store might be 20 by 40 feet, with shelving along the walls, a counter, and storage areas in the back or upstairs. The store might also serve as a post office, a meeting place, and a social center for the community. The construction techniques for these larger buildings differed from house construction primarily in scale. The framing was heavier, larger timbers for longer spans. The foundations might be more substantial, stone or brick piers rather than simple wooden sills. The finish work might be more elaborate, glass windows rather than shutters, painted or whitewashed interiors rather than exposed wood. The window glass for frontier buildings was often one of the few components that had to be brought from elsewhere. Glass manufacturing was industrial and couldn't be done on site. Windows would be ordered through supply networks and shipped by wagon or rail. Until the glass arrived, window openings might be covered with shutters or oiled paper that admitted light but not as much cold or wind. The nails used in frontier construction were expensive relative to labor costs, which influenced construction techniques. Wooden pegs were used wherever possible to save on nail costs. Mortise and tenon joints needed no nails. Log buildings used relatively few nails, but frame buildings with siding required substantial quantities of nails, perhaps 20 to 30 pounds of nails per house. These nails were typically hand-forged, though by the late 1800s, machine-made nails were becoming available at lower cost. The chimney construction for houses and buildings was skilled work that required experience. A poorly built chimney could cause fires, or might not draw properly. Frontier chimneys were typically built from stone, if suitable stone was available, or from brick, if a brickmaker was present. In some areas, chimneys were built from wood lined with clay, a cheaper but more dangerous option. The chimney builder was often a specialist who moved from project to project. The timeline for building a frontier town varied, but 90 days was aggressive even with a dedicated workforce. A more typical timeline might be one full construction season, May through October, with the most essential structures completed in the first 3 months and additional building continuing through fall. But there are documented cases of towns being substantially complete in 90 days, when the workforce was large and well organized. The town of Greeley, Colorado, established in 1870, was built remarkably quickly by a colony of settlers who arrived in May and worked through the summer to construct their community. By September, they had built over 50 houses, a hotel, a church, a school, and various commercial buildings. The construction was documented in letters and newspaper articles that described the pace and organization. The Greeley colony was organized by Nathan Meeker, an agricultural reformer who recruited settlers from the eastern states. The colony members were required to pay membership fees that funded the initial construction. They arrived in Colorado in May 1870 to find the town site marked but completely unbuilt. The construction organization was military-like in its efficiency. Crews were assigned specific tasks. A sawmill was erected first, powered by water from an irrigation ditch. Logging crews cut timber from nearby canyons. Construction crews worked simultaneously on multiple buildings. The colony members lived in tents and temporary shelters for the first month, while the communal dining hall and bunkhouses were built. By July, individual family houses were being constructed at a rate of 4 to 6 per week. The houses were frame buildings, typically 20 by 30 feet, with 2 or 3 rooms. The construction was standardized. all houses built to the same plan, which accelerated the work by allowing crews to repeat the same operations without having to learn new configurations. By September, the town had a population of about 200, with accommodations for everyone. The colony had spent approximately $30,000 on construction, about $900,000 in modern currency, including materials, labor, and tools. The success of Greeley demonstrated that organized, coordinated construction could create a functional town in a single season. The town of Ellensburg, Washington, rebuilt after a devastating fire in 1889, accomplished similar rapid construction. Though this was rebuilding rather than initial construction, the speed was comparable. Dozens of buildings erected in a few months using local timber and coordinated labor. The fire occurred on July 4, 1889, destroying most of the business district. Approximately 10 blocks of buildings burned completely. The rebuilding effort began within days. The town was a county seat and commercial center, so rebuilding was economically essential. Local lumber mills operated at maximum capacity. Construction crews were recruited from across the region. By October, 4 months after the fire, the business district had been substantially rebuilt, with over 70 new buildings completed or under construction. The Ellensburg rebuilding demonstrated a slightly different model than initial town construction. Rather than a coordinated effort to build an entire town, this was dozens of individual property owners rebuilding simultaneously. But the effect was similar. A destroyed town recreated in months through concentrated effort and local timber supply. A third example is the town of Panguitch, Utah, established by Mormon settlers in 1864. This town was built even more rapidly than typical because the settlers were experienced in cooperative construction from building previous settlements. The construction was organized by the church leadership, which assigned families to specific tasks. The entire community worked together to build houses, a meeting house, a school, and fortifications against potential Indian attacks. The Panguitch settlers arrived in April, and by July had built enough houses and structures to survive the coming winter. The construction used local timber from nearby mountains, hauled by ox teams to the town site. The houses were primarily log construction, built quickly and simply. The meeting house, which served as both church and community gathering place, was a frame building erected by the entire community, working together over 2 weeks. The success of Panguitch and similar Mormon settlements came from the organizational structure provided by the church and the experience the settlers had from building previous communities. This wasn't their first frontier town. It might be their third or fourth. They had refined the techniques and knew how to organize the work efficiently. The physical demands of frontier construction were extreme. Building work is physically taxing under any circumstances, but frontier construction combined heavy labor with long hours and primitive living conditions. Workers might labor 12 to 14 hours per day, 6 days per week, living in crowded bunkhouses with poor sanitation and limited food variety. The injuries common in frontier construction included the usual building trade hazards: falls from scaffolding or roofs, cuts from tools, crushed fingers or hands from heavy timbers, back and joint problems from heavy lifting. But frontier construction added additional risks from the isolation and lack of medical care. An injury that might be minor in a city with doctors and hospitals could be serious or fatal in a frontier location days away from medical help. The weather was both an enabling factor and a challenge for frontier construction. Summer and fall were the construction season because temperatures were moderate and daylight was long. But summer storms could halt work and damage partially completed structures. Fall brought the pressure of approaching winter. Construction had to be finished before snow made work impossible and before cold weather made partially completed buildings uninhabitable. The transition from construction phase to occupied town happened gradually as buildings were completed. Families might move into their houses as soon as the basic structure was weather-tight, even if interior finish work was incomplete. The store might open for business as soon as the building had walls and a roof, with shelving and other improvements added over time. The town became functional before it was truly finished. The success of rapid town building depended on multiple factors aligning: adequate timber supply within reasonable hauling distance, a workforce with appropriate skills, carpenters, sawyers, loggers, a source of essential supplies that couldn't be made locally, nails, glass, tools, organized leadership to coordinate the work, and sufficient capital to pay workers and purchase supplies until the town was established and could generate its own economy. Many attempted frontier towns failed. The timber might prove unsuitable or too distant. The workforce might be inadequate or undisciplined. Supplies might not arrive. Winter might come early. Disease might strike the workers. The survival rate of frontier towns was probably less than 50%. For every town that succeeded and grew, another was abandoned or failed to thrive. The towns that did succeed created the foundation for permanent communities. The buildings erected in 90 days might last for decades. Over time, they'd be improved. Log cabins might be covered with siding. Crude interiors might be plastered and painted. Temporary roofs might be replaced with better materials. But the basic structure, the layout of streets, the location of buildings, the organization of the community, was established in that initial rapid construction phase. Today, some frontier towns still contain buildings from their original rapid construction period. These structures, often heavily modified and restored, stand as evidence of what was accomplished. A log cabin house that was built in a week in 1875 might still be standing in 2025, now a historical building or museum. A church built in a month in 1880 might still serve a congregation. These buildings connect the present to the frontier era and demonstrate the durability of well-executed construction, even when done rapidly with simple tools. The techniques used in frontier town building, log construction, frame construction with mortise and tenon joinery, hand-split shakes for roofing, these were skills developed over centuries and refined through practice. The workers doing frontier construction weren't inventing techniques. They were applying established methods in challenging circumstances with limited resources and aggressive timelines. The legacy of frontier town building extends beyond the physical structures to the organizational and social patterns established. A town built quickly by coordinated group effort developed a sense of community identity. The people who built the town together had shared experience and shared investment in its success. This social cohesion helped communities survive the challenges of frontier life. The frontier town building era lasted roughly from the 1840s through the 1890s, as the American frontier was settled. By 1900, most accessible areas had been claimed and developed. The era of rapid town building, from forest to community in 90 days, was largely over, replaced by more conventional development, where materials were shipped in and construction proceeded at a more measured pace. But for those 50 years, thousands of towns across America were built using the techniques described here. Groups of workers arriving at forest sites in spring, cutting trees through summer, constructing buildings rapidly, and creating functioning communities by fall. The speed and scale of this development is difficult for modern people to comprehend. We're accustomed to construction taking months or years, even with power tools and industrial materials. The idea that 50 men with axes could build an entire town in 90 days seems impossible. But it happened. The evidence exists in the towns themselves, in construction records and journals, in photographs showing newly built frontier towns with stumps still visible where trees were cut weeks earlier. 500 trees became 30 houses, a church, a school, and a store. 90 days of dawn to dusk labor, 50 men with axes, saws, chisels, and determination. A community created from forest because there was no alternative and no time to waste. That's how America built towns on the frontier. And the speed of it, the sheer audacity of attempting and accomplishing it, deserves to be remembered.